The proof of this theorem uses the uniform contracting property of the Eskin-Margulies head function. And this is in their 2004 paper. The first thing we want to do is that we want to introduce some notations. We'll get them through the finite dimensional linear representation for a finite dimensional representation rho of the Lie group G where V is equipped with the norm. For real number lambda, we denote this is so-called the lambda Lyapunov subspace of A sub f. Remember, A sub f is a diagonalized part. Is a diagonal part of f, and we consider the subspace V sub lambda for all those V in capital V. That is an eigenvector of rho of AT with eigenvalue e to the power lambda t. Since AF is diagonalizable, these are diagonalizable. We can write the space V as a direct sum of three parts. Where V plus the direct sum of lambda Lyapunov subspaces with lambda greater than 0, and V negative with direct sum of those negative parts. Now we consider the adjoint representation of the Lie group G. And this is the Lie algebra of G. And the decomposition here becomes G equals to the direct sum of G plus G0 plus G negative. And they're all Lie sub-algebras of G. And we give this part a new notation, call it GC. Now we denote the connected subgroups G plus and G minus. The D groups of the Lie algebras G plus and G minus. And G sub C is the kinetic component of the centralizer of A sub 1, which is in A sub F, the one parameter subgroup. Whose D algebra is G sub C. And furthermore, we use notations D, dc, d minus for the manifold dimensions of G plus, GC, and G negative, G minus, respectively. Let BRG be the ball centered as a neutral element of the G with radius r. And respectively, we have the following sets. And finally, we let mu be a Haar measure on G plus with mu of this unit ball. This corresponds to this guy. This unit ball, the measure of this unit ball equal to 1.